the factor theorem. This lesson will look at the factor theorem and how we apply it to factorising cubics and solving equations. First we'll go back and have a look at quadratic functions. If we consider the following function, x squared plus 2x minus 3, it's easily factorised by inspection, and we get x minus 1 times x plus 3. And from the factors we can see that the zeros of the functions, the roots, are x equals 1 and x equals minus 3. In other words, the values that would give us f of x equals 0, where this equals 0. If we put them in, so instead of x we place 1 into the function, so 1 squared plus 2 times 1 minus 3 gives us 0, and if we put minus 3 in we can see that it also gives us 0. The factor theorem is like the reverse of this process. It enables us to find factors easily. So looking at a cubic function, we've got this function here. If x equals minus 1, we put f of minus 1 in. Minus 1 cubed gives us minus 1. Minus 1 squared gives us 1. 7 times 1 gives us 7. 9 times minus 1 gives us minus 9 plus 3. We add them together, we find we get 0. Notice the change of sign, f of minus 1 and the plus 1 in there. Remember, we need to make the bracket 0, so if x is minus 1, the bracket is 0. So we can say that through the factor theorem we know that x plus 1 is a factor, and this works for anything. If fa equals 0, then x minus a is a factor. So that's the general rule. So if we want to find a factor of this cubic here, let's try 1. Try the easy numbers first. If we put 1 in here, we get 1 cubed minus 2 times 1 squared plus 3 times 1 minus 2, and we do get 0. So that tells us that x minus 1 is a factor. Once we've found one factor of a cubic, the other factor is a quadratic, and we can generally factorise it. In fact, the examples you're likely to get in AS Maths will be fairly easily factorised by inspection. So factorising this fully, we use the factor theorem to find one linear factor. We know that any linear factor must be a factor of 8. It must include a factor of 8 because the three numbers at the end of our three linear brackets will multiply out to 8. So we can try only these possibilities. We generally try the easy ones first. F of 1, well, if we put 1 in, you can see we get 12, which obviously isn't 0, so x minus 1 is not a factor. However, maybe looking at those numbers might suggest that if we put x as minus 1 in other words x plus 1 is a factor, we might be more lucky. So if we try that, we do get 0, so we know x plus 1 is a factor. So we know then that this cubic, the one we started with, has x plus 1 as a factor, and the other factor will be a quadratic. It's not that difficult to find this quadratic. We can do this by inspection. the first term we've got here in our cubic is x cubed. The last term is plus 8. Now we know that x times the x squared term is the only way we'll get an x cubed term. So that tells us that we've only got single x squared. We also know that this number times the number at the end will give us the plus 8. So we can instantly place two of our terms for the quadratic without really much thought at all. That just leaves the x term in the middle. How many x's do we need? And to find this, we look at how many x squareds we've got here. We've got minus 2 lots of x squared. If we look here, we're going to get x squared two ways here. One way is by multiplying the number here by the x squared term here, and we've already got that. That gives us plus 1x squared. The other way will be to multiply the x term by the x term here. That will give us our second x squared term, which will then gather together and has to become minus 2x squared. So because we've got plus 1x squared, we need minus 3x squared to make it minus 2x squared, to make it what it needs to be on the left hand side. So we put minus 3x squared in there, or rather we put minus 3x, so that when it multiplies with the x here we get minus 3x squared. And we now have the right number of x squareds. And that's it. That's how we factorise. You'll notice we haven't used the 5x term. You can use that to check. The way we'll get x terms here is plus 8 times x there. That gives us plus 8x, and plus 1 times minus 3. Well, 8 minus 3 gives us 5 lot of x, so we can see that it works. So we can use that to check. Like so. Okay, now let's see if we can factorise this quadratic. And we can see that actually in this example it doesn't. But if we could then make it into 3 linear factors. So we end up with this factorised form of the cubic. So to summarise, to factorise cubic functions we use the factor theorem to find one linear factor, and this is the factor theorem. If f of a equals 0, so when we put a in instead of x, whatever a is, then, and we get 0, then x minus a must be a factor. We find the quadratic factor by inspection. We start with the x cubed term. We find the constant, the number at the end, and we use the x squared terms to find the middle term of the quadratic, and then we can use the x term to check. If the quadratic left factorises, then we factorise that as well, and we end up with 3 linear factors. Okay, well that's all you need to know for now. So have a go at these 3 questions. If you're successful, then you're ready for the lesson. Pause the presentation, have a go at fully factorising them, and then check the answers. Okay, so here's the answers. And that does factorise into 3 linear factors, as you can see. So does the second one. The third one factorises like this.